Everybody, it's me, Miss You, and today we're going to be working in 1.3.4. What I'm going to be doing right now is what we did in class and what you need to do for class credit today. We're going to move the cube to have a front view, and we're going to create a rectangle, a center-based rectangle that is 6 inches horizontal and 4 inches vertical. So let's begin. Let's create a sketch. Let me do the front and let me select a rectangle with the center. This is best practice to center things on the center. And we're going to constrain it with dimensions. So let's pick the dimensions. Across is 6 and vertical is 4. And here we go. We have a 4 by 6. Okay. Next, what we're going to do is we're going to bring in 3 polygons. One is a pentagon, one is a hexagon, and one is a triangle. We bring them in by using the inscribed pentagon, but you could also use the circumscribed one. That means the circle's on the outside. I personally like the inscribed one better because I find it less messy when drawing. So I'm selecting it. Next, I'm doing a hexagon. And let me go. I don't want an 11-sided figure, so I am going to change it. I change it by selecting the arrow, and my first one is going to be a pentagon. My second shape, I'm going to select the inscribed polygon, is going to be a hexagon. Okay, no, it's already a hexagon. Great, I just go enter. And my third one is going to be a triangle. Okay, so let me just select the inscribed shape. And it is a triangle. And I'm going to select it. And now I'm going to double click on the 6. And I'm going to write 3 because it's 3 sides. And here I go. I have a triangle. Next, we're going to work on the radius of the inscribed circle. I think the inscribed pentagon has a circle has a radius of 0.35. Doubling it for a diameter, we want it to have a diameter of 0.7. Okay, so I zoomed in. I'm selecting the circle. Oops, let me select the circle. And now I'm going to go to the dimensions. And here I am. And my dimension is going to be 0.7 for the pentagon. Okay. For the hexagon, it's a radius of 0.25, so that means the diameter is 0.5. So I'm going to select the inscribed circle, and I'm going to make the diameter 0.5. Okay, and it's an equilateral triangle, and the sides are all 1.25. So I'm just going to select the side, and I'm going to call that 1.25 inches. Okay, all the sides changed. Let me recenter everything. Okay. The next step that we're going to be working on is a few more constraints. We want the center of the pentagon on a vertical line through the center of the rectangle. So in order to do that, what we're going to do is we're going to draw a line through the center of the rectangle. We're going to go along the line until we get to the center. Here we go. And now we're going to make sure that the center line is, that line is horizontal. And we have a line through the center. We want that to be a construction line. So we're going to highlight it. or select it, and then we're going to go look up here where it says construction Q, and now it becomes a dotted line. Okay. The next step that we're going to do is we're going to make the center of the circle, okay, coincident. We're going to take off the construction line, select the center, select the line, and we're going to make it coincident. So here we go, coincident. Whoops, the center and the line, and now they're coincident. Okay, that means that the pentagon will always be on the line. This line is no longer, I think I selected it construction, so I'm going to bring it back to being a construction line, so it's not part of our drawing. There we go. What else does it say about the pentagon? I think the pentagon, one of the sides is going to be horizontal. One side of the pentagon is horizontal and is located 0.5 inches above the center point of the rectangle. So I want you to just pick one of the sides. Okay. Pick one of the sides. There it is. And make it horizontal. And it should turn. So it looks like this. And you want the distance between the bottom and the center to be 0.5. Because it says one side of the pentagon is horizontal and located 0.5 inches above the center point of the rectangle. Okay, so we're going to select the dimension tool. I'm going to select a line, and here we go. And it is 0.5. And there it is. Okay, it's now 0.5 from the center. Next, we're going to work with constraining the hexagon. One side of the hexagon is parallel with the 6-inch side of the rectangle. So you're going to select a side. Okay, if you're having trouble selecting it, just zoom in. It makes it a little easier. Whoops. Take off your dimensions. Just select one of the sides and then give it a horizontal constraint. There it is. The center of the hexagon is coincident with the diagonal of the rectangle. So we're going to have to create a diagonal to this rectangle. Okay, let me recenter it. So we're going to create a diagonal by first creating a line and then turning it into a construction line. Here it is. Here's 1, 2. It's a construction line. Now I'm going to highlight the diagonal. And we're going to turn it into a construction diagonal. And there it is. Okay? Once we have a construction diagonal, we want to make it coincident with the we're going to make it coincident with the diagonal. So what we're going to do is we're going to select the center of the hexagon, and then we're going to select the diagonal, and then we're going to select the coincident constraint, and it should move. All right, hopefully this is what your part looks like so far. For number 6E on 3.4, the instruction is the center of the hexagon is 0.5 inches below the top side of the rectangle. So the center, so this is the center. The center of the hexagon, so I'm going to put on the dimension tool. The center of the hexagon is, select the center, and then we're going to select the top, and we want this number to be 0.5. And there we go. Our hexagon is now placed. For 6F, we're going to start working, it's with the triangle. One vertex of the equilateral triangle is coincident with the corner of the rectangle. So we want to take one vertex of the equilateral triangle. Okay, here is the vertex, and we want to make it, let's take off the dimension constraint. So you want to be able to select a vertex, and you want to select the corner of our rectangle, and we're going to make it coincident. Okay, so I want to show you that this triangle could move right now. Should be able to move. Yeah, there it is. It could move because we have only one point constraining it. Okay, so we just constrained one point, that tiny corner, and the next thing it says for 6G, the center point of the equilateral triangle is coincident with the diagonal of the rectangle. So we're going to create another diagonal. I thought it would be fun just to have one shape on one diagonal and another shape on another. Here's one. Here's the other. So I have a solid line. And now I want to turn it into a construction line. I want to select it. And then I want to select construction line. And it went into a construction line. So there we go. And now we want the center of the triangle to be coincident with the second diagonal. So what I'm going to do is I'm going to select the center point, select the diagonal, and I'm going to make it coincident by selecting the coincident constraint. And there it is.